Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. Imagine you want to estimate the relationship between education and wages. You collect data, run a regression, get your results. Everything looks reasonable. But there is one problem. Your dataset only contains people who are employed. Everyone who is unemployed is missing. Can you still use your results to say something about the entire population? Well, not necessarily. This is the problem of sample selection bias. And crucially, nothing is wrong with the regression itself. The OLS estimation is fine. The problem is entirely in the data that enters the regression. Why does this matter? Let's ask, are employed individuals similar to unemployed individuals? Okay, so we still have education and earnings, okay? Or wages. So the question that we have is, are employed individuals similar to unemployed individuals? And the answer is usually not. They differ in education, skills, experience, tenure, motivation, health, location, and local labor market conditions. So the people we observe are systematically different from the people we don't observe. Okay? And if those differences are related to wages, which they almost certainly are, then our estimates of the education-wage relationship will reflect the selected sample, not the population. Suppose two individuals have exactly the same years of education. So imagine we've got person A and person B. Person A, employed, so appears in the data set. Person B, not employed, so it's unemployed, which means not in the data set. Now, person B vanishes not because they don't exist, but because the selection rule says only employed people have observed wages. Now, imagine this happening repeatedly throughout the data set. Does the observed sample still represent everyone with that level of education? Probably not. The employed subset is not a random draw from the full group at this point. Now, the problem isn't simply that observations are missing. The problem is why are they missing? Okay. And this is where we have this idea of the selection rule. Okay. So let's think of the different examples. So we've got example one, we have observed wage. The condition, only if employed. Example two, let's say observe loan default. Well, only if loan was approved to begin with. And let's say another example. Observe uni GPA. Well, you can do that only if student actually enrolled at uni. Okay, so in each case, in a sense, there is a hidden gatekeeper, an implicit rule that decides. So in every case, we had an if So we had an implicit rule that decides which observations become visible. And the thing is, this gatekeeper is not random. It selects based on characteristics that are related to the outcome that we're studying. So this gatekeeper, this selection rule, is exactly what the Hackman model formalizes later with the selection equation. So just keep this picture in mind, a two-stage process where the first gatekeeper decides who enters a sample, then we observe the outcome for those who do, okay? Graphically speaking, if we wanted to show all of this, imagine that this is your entire population. This is all what you are observing. Normally, we would fit a line that sort of looks like this, right? Seems quite representative of what we have. So this is the true. Well, imagine now that all of a sudden we don't really observe anything, let's say down here, lower corner where it's low income, low education people, okay? Well, look at the scattered data now. If I were to feed a line in here, wouldn't really look that steep. It's probably going to be more like this. Okay? So the cloud of points changed shape once I took this lower left corner, which is empty, okay? And the estimated relationship also changed. Now, it changed not because the underlying truth changed, but because part of the population simply disappeared from the data. Okay, so now you've got both a different slope and a different intercept. And we are estimating the relationship among the selected people here, not the entire population. And I would say, keep in mind, the same data generating process, you've got the same true relationship, but a different regression line just because of who is missing. And in terms of like real world examples, just like the way we were talking about earlier, you can think of labor economics, where wage is estimated from employed workers only. You can think about others like housing prices, which are estimated from properties that are sold, and so on. So in every case, the missing observations are not random due to these gatekeepers that we mentioned earlier. They are concentrated among specific types of individuals, and those individuals differ systematically from those we observe. Okay. Ultimately, keep in mind, suppose that we've got few survey responses that are lost due to a computer error, completely random. Now, in that case, we mainly lose information, so estimates definitely become less precise, but not necessarily biased. So that would mean sample selection bias is different. In this case, observations are missing for a systematic reason, okay? So systematic reason. One that is related to the outcome we're studying. So random missing data. So if we just simply had random missing data, then we have a precision problem. Sample selection bias. Well, that is an accuracy problem. Okay. Now, the distinction here mirrors the one we've already seen earlier between heteroscedasticity and omitted variable bias. So heteroscedasticity, we've got a precision problem. Omitted variable bias, we've got an accuracy problem. Now, the pattern recurs throughout econometrics because random disturbances, they will cost you precision. However, it's a systematic disturbances that will cost you a bit more, and they will cost you in accuracy. Okay. So To conclude, once again, sample selection bias arises when the probability of entering the sample depends on characteristics related to the outcome, causing the observed sample to systematically differ from the population and the estimated relationship to answer the wrong question. Now that we've seen that sample selection bias isn't about running the wrong regression, but it's about estimating the right regression on the wrong sample, with this like gatekeeper at the heart of the problem, it means that now we'll need to draw that gatekeeper into a path diagram and see exactly what kind of bias it creates in our estimate. And we'll see that in the next video. So stay tuned and I'll see you then.